Hello, calculus students. In this problem, we're going to solve a linear motion um, problem here. So we're going to compute some velocities, and we're going to determine some times at different events. Now, the position of the diver executing this dive from a 10-meter platform, okay, this is the position function. Now, notice that S is in meters, so the unit of this thing, this expression here, will be in meters. So you can use the units to help you with the interpretation of what you're trying to find. So the position's in meters, time is in seconds, and velocity then is going to be in meters per second. So we'll focus on trying to match up our units and using that to guide us. Okay, so the first thing we're going to do is compute the velocity. Remember that the velocity is the first derivative of position, so it's the rate of change of position. So if I take this derivative of this function, I get minus 9.8t plus 2, so that means the velocity is given by this expression here. So I'm just going to box that in, and we're going to need that for later. Okay, so let's get into answering the first question. When t is 1 second, what is the velocity? That's what this first question is asking us. Well, I have the velocity function, so I'm just simply going to plug 1 into the velocity function, and I'll get minus 7.8 meters per second. Now, it's negative because the diver is going downward off the platform. Okay, let's answer the second question. What is the velocity when the diver is 5 meters above the water? So remember, S is in meters, and we're given 5 meters, so that means the position of the diver is 5 meters. So this function here is the position function, so that's what we set equal to 5 meters. The diver's position, this here, the position is 5 meters above the water. But the question is asking you when the diver is 5 meters above water, so we're going to have to determine a time, and once we know that time, we'll determine the velocity. So it's building on the concept that we answered in the first question. You're given a time, you're able to determine the velocity. Now, you're given a distance, you have to determine a time, then you'll determine the velocity. Okay, so let's solve this expression to get the time, determine that when. We'll just set the position function equal to 5. We'll subtract 5 from both sides. We'll get this expression here, so 10 minus 5 is 5. And now we're going to solve this quadratic equation, and we're going to use the quadratic formula to do so. We'll get 2 times, a negative one and a positive one. And since this is a physical problem, we're going to disregard the negative time, the time that's less than 0, and we'll take the positive time. But since we're only, our equation is only for 1 digit of precision here, or sorry, 1 decimal place of precision, we're going to use 1.2 to input into the velocity. So just as we did in the first problem, now we have the time, which is 1.2 seconds. We input that into the velocity function, and we get that the diver is going minus 3.9 meters per second when she is 5 meters above the water. Okay, when will the diver hit the water? This problem is similar to the previous one, when 0 meters above the water in this case. So in this case, when will S of t equal 0? So let's set the position function, which is meters, equal to 0 meters. All right, and then we solve that using the quadratic formula, because that's a quadratic equation, and we get 2 times, a negative 1.2 seconds and a negative 1.6 seconds. Now that we have that time, that's when the diver hits the water, we can tell how fast the diver will be traveling at that time. So we are really trying to find out what's the velocity. Take that time, plug it into the velocity function, and you get minus 5.8 meters per second is the velocity when the position is 0, or minus 5.8 meters per second when the diver's hitting the water. All right, that's the solution. Good luck.